Hello everyone, I'm Maitri and Skanda. We have created this home automation project using IoT, that is Internet of Things and embedded systems. So in this presentation, we will be coming across what is Internet of Things, what is embedded systems, what is the hardware and the software used, what we have learned throughout the internship course, requirements, projects and the output. The basic idea behind the project is to create a home automation using Arduino and Blynk application. So here, instead of using actual hardware, we are using a simulator, that is using PicSimlab, and then we are using a Blynk mobile application to control these devices. The home automation should be simulated on the PicSim simulator. Blynk IoT mobile application used to control the devices should be able to control the lights, temperature of the home, inflow and outflow of water in the water tank. Internet of Things, the network of physical objects that contain embedded technology to communicate and interact with their internal states or the external environment. The Internet of Things describes a network of physical objects, that is, the things that are embedded with sensors, software and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. One example is the automotive industry, which uses IoT devices in the manufacturing process. The automotive industry extensively uses industrial robots, and IoT can help proactively maintain these systems and spot potential problems before they can disrupt production. Embedded system. Any combination of hardware and software which is intended to do specific tasks can be called as embedded system. What is embedded system in IoT? An IoT embedded system is an embedded system that has internet connectivity. Another word, what is IoT embedded system is a smart device. A touchscreen and a keyboard are not necessary to define a device as an IoT embedded system, although these peripherals can also be attached. So here we are using Blynk application Arduino to implement C programming, which is used in the project, and we are using Blynk application to control our devices, and then instead of using hardware we are using the simulator, that is PicSimlab. So here embedded system is a combination of computer hardware and software designed for a specific function. Arduino Uno. The Arduino Uno is a microcontroller board based on the AT-Mega 328. It has 14 digital input-output pins, 6 analog inputs, 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. In the internship, we learned the basic concepts of C programming and OOPS concepts. We understood what is Internet of Things, what is embedded systems, and the working of Arduino and PicSimlab. The requirements. The software requirements are PicSimlab, Arduino, Blynk IoT, Null emulator. The hardware requirements are LED, LDR sensor, temperature sensor, PCF 8574. Ethernet. Instead of using Wi-Fi, we are using Ethernet to connect to the Blynk IoT application and the PicSim spare parts. LCD, where we are showing the temperature, volume and whether the heater is on or off. All of this is shown in the CLCD, which is LCD HD 44780, and the Arduino Uno. So now explaining what our project is based on. In the project, we are controlling 3 devices. As already mentioned, the first one is the garden light. How the garden light will be used, to be precise, the smart working of lights. When there is less availability of lights or absence of light, the light turns on and turns off during the daytime. So we are using this as LDR sensor value based on the reading from the LDR. The vary of brightness of the LED will occur. It will be controlled according to the availability of sunlight. And the inputs are LDR sensor and output garden lights. Then we are using temperature control system. Here we can control our temperature of the room from our phone by clicking on the on and off buttons on the app and seeing how much temperature is there in the room. We are including a heater and a cooler after reaching a specific temperature that is said to be 35 degrees, and the cooler will automatically turn on and decrease the room temperature to 27 degrees Celsius, which is minimum temperature. We are showing the temperature of the room in the CLCD, and knowing the status of the heater and the cooler, we decide whether to turn on or off, controlling all of this using the Blynk IoT application. Here the input is temperature sensor and the output is they display the temperatures on the CLCD. Next we have water tank, in which we are using inlet and outlet valve control. Um, Here we are reading the volume of the water stored. According to that, it will be shown on the CLCD, and same as for temperature. Now, as we on the inlet valve, the water will start filling into the tank, and through the outlet valve, the water will flow out. This can be controlled using the Blynk application app, which we are displaying all of this on the CLCD. Then comes the Blynk application. Blynk was designed for the Internet of Things. It can control hardware remotely. It can display sensor data, can store data, visualize it, and do many other cool things. Create widget on the mobile Blynk application. Button widget to control the heater, cooler, inlet valve, and the outlet valve. Gauge widget to display the temperature and the volume of water in the tank on the mobile application. Terminal widget to display the notifications whenever a threshold is crossed, like temperature is more than 35 degrees, turning off the heater, water level is full, water inflow disabled. This is the output of our project. We are using all of this in the PicSimlab, and there is a cereal tank. Now Skanda will explain the working of the project.
So yeah, my name is Kanda. So I am here to explain the project as my friend Maitri did all about the PPT and stuff. So this is the program which we have written in Arduino. So here we are trying the IDE which we are using is Arduino, as I told. So we are declaring different types of header files which include hash include serial tank, temperature system, main, and everything. And here we also create different methods for the project. So those methods are cooler control off, so which is used to trigger different functions in a cooler. And then we also have used a method like heater control on and heater control off. So this will display the heater is on or heater is off. Those are the special characters used. And this is the same thing for the inlet and the outlet valve. So for the serial time, so the water starts flowing and the inlet is on or the outlet is on, so whatever is on or off will be shown there. And then here we are this is for the LEDs or the brightness of the LEDs which we are trying to focus. So these are the whenever the sun is high, that sunlight declaration, the sunlight light will be taken and that will be declared. And now we move on to ldr.cpp function. So this is used for the operation of LDR, and we have written the thing in which control of the brightness of LED will be done over here. So everything whatever related to the LED will be done here. And here we include two header files. So with the control of the brightness, we just do the thing. And here we move on to the main function. In main function we include all the header files like temperature and all those things. And here these are the virtual pins from V1 to V6 which are used in Blynk app. Now we move on to serial tank.cpp. This is used for the serial tank. And here we are going to uh, like the work, like with provided functions over here, we it is showing us if the tank value or the volume of the tank is greater than this, then you have to stop it, or enable the inlet valve, disable the inlet valve. So this is for enabling inlet, this is for disabling the inlet, and this is for enabling the outlet, and that is for disabling the outlet. So these are the functions which we have used, the marking ones. And then now moving on to serial tank.h. This is same what we are doing here is I'm telling in here, like these are the same thing, but we are using different kinds of header files to explain them. And then here we have temperature system.cpp. This is for the cooler and the heater. The temperature of the room what we are used, see, that is for the heater and that is for the cooler. And then the next one what you're gonna do here is then we're gonna read the temperature. We're gonna read the temperature, that is read temperature and give whatever it is. If the temperature is high, the cooler cools it, and if the temperature is low, then the heater will heat it. So now we are going to open PicSimlab. PicSimlab, this is the board which we have used, Arduino Uno board, and now these are the spare parts which we are going to use. So this is the CLCD display which we are going to use. So here temperature, volume, cooler off, inflow off, everything will be seen here. And now what are we going to see next? So yeah, this LCD display is also used for showing everything, and these are the LEDs which are used with the brightness detection, and if the brightness goes low and everything. And this is the LDR sensor, so where we can use as the sunlight thing, you can dim it down and go up, and we can decrease and increase the brightness as we require, and as low as the brightness goes and comes up, that is the sun's brightness. And now the next one, what we're gonna see is the yeah, I did explain the LEDs. So the next one which you're gonna see is the fan or the heater or the cooler. So heater or the cooler is nothing but to increase or decrease the temperature. And now we're gonna see the serial tank. So serial tank, which will show us the inlet, if the inlet valve, and which we can see that is the inlet, and this is the outlet valve where water will go out. And we have to connect the serial tank. So we'll connect it now. Hmm. So yeah, with the help of the tools, we'll add it to the serial tank. We'll use COM2 here, and we'll connect it now. Oh no, COM1. Yeah, so now whatever you can see is the Blynk app on my phone. So in this Blynk app, what we'll do is this is used as a software for the hardware, whatever it is. And here you can see we have the heater on button, cooler on button, and we can see that the heater is on in the LCD display, and the temperature is rising, and it reaches a certain point, it will automatically off. And then and then we have the cooler on button, where once we click it, you can see the cooler on is showing over there, and the temperature is decreasing, and here it shows cooler on and fan started rotating, as you can see. Okay, and then now moving on to the serial tank, we had here oh wait, yeah, yeah, then this is the app for the inlet and the outlet valve. So the output of the outlet valve is serial tank, is that the water tank what we are doing. This is the water tank what we are seeing. As I on the inlet, the water comes into the tank, and then we can see that the tank is filling, and here the volume is also increasing, and then it is in return flow also, the inlet is also flowing, and here also the volume is increasing inside my Blynk app. So now as the water stopped, you can see that the gauge, we call it as the gauge, at the certain level has stopped, and the outlet valve is now on, so for which my water is flowing out. Sorry, yeah, so this is the level where it is showing that it is decreasing to, and the outlet flow is on. And here in the water volume gauge also, we can see it is going down, the water level is decreasing. And now 1 minute, uh, sorry. So yeah, now this is the LED which we used, as I told you before, to increase and decrease the brightness of the LED, and this is also working. And now in the Blynk app, we can see we have two tabs. This is the notification tab, and then we have this is the gauge tab, as I told you, and then we have the cooler off button and the heater off and on button, and then these are called the widget buttons. Okay, so these are called the widget button, and these the measuring one is called as the gauge. And then we have tab 1 and tab 2. Tab 2 is used for the inlet and outlet, as I told. This is tab 1, and the second one is used for inlet and outlet for the serial tank. So generally Blynk is used to connect with the hardware for a virtual thing. Okay, so now we reach the conclusion of the project. Using Blynk IoT application and PicSimlab Simulator, we have successfully created a home automation project. Here, LEDs, temperature system, and a serial tanks can be manipulated. They're using light sensors, heaters, coolers, inlet and outlet valves, okay, in real time. The CLCD acts like a dashboard, which we can call it as a simple overview of whatever happening at an instant at the present time or the real time. So we also make use of widgets from Blynk IoT app. So there are two kinds of widgets. button widgets and gauge widgets. Button widgets are used for switching on and switching off heater, cooler, inlet valve, etc. And gauge widgets are used for measurements, that is the volume of the water and the temperature. Now we would like take this time to thank the organization Emertxe, which gave us this beautiful opportunity to be an intern. And then we would extend our heartfelt thanks to our director and the mentors, Jailakshmi ma'am and Anusha ma'am. Your guidance and the support have been invaluable to us, and we have learned so much during our time here. We are very grateful for the chance to work alongside such talented professionals and for the knowledge and experience that we have gained. Thank you for everything. Thank you, Emertxe.